Hello, my name is Professor Johnson, and today I will be showing you factoring by grouping, or otherwise known as the AC method. Now, this is our most basic example, and I'm going to start with a quadratic function in the form ax squared plus bx plus c, where in this problem a equals 1. And this is going to be the most basic because when you look at the AC method, a times c is just a 1 times a c. But before I get into the AC method steps, I'm first going to look at this just overall. So just look at these three terms. A is 1, B is -4, and C is -5. And when you look at each of these, what we need to do is factor. So we need to have some kind of grouping of terms that would simplify this x squared. And because x squared has a single 1 in front, our first term you could think of as an x times an x, because when you FOIL this back out, x times x gives you x squared. Now, in the end, you have a -5. What are the factors of 5? The factors of 5 is just 1 times 5, or you could think 5 times 1. But those are truly the same number. So 1 times 5. 1 times 5 would have to be in the last spots, but you want a negative, and the only way to get a negative is to have either a minus plus or a plus and a minus in the in-between. But in the middle, you want the middle to add up to -4. Now, how does that work? You would have to have, to get -4, you'd have to have the 5 being negative, because then when you have a -5 and add a +1, that will give you a -4. So this truly is the factored solution, but that is just doing guess and check. And guess and check is not always the best method, because when problems get more complicated, you can easily get stuck. But with this one, because the A term was 1, guess and check works pretty nicely. But using this nice one that we know the solution to, I am going to show what's called the AC method. Sometimes other books call it grouping. Okay, it's called also the grouping method. Okay, now AC method. A and C, you could think of it as the A and the C from up here. The A was 1 and the C was -5. Now, what happens when you multiply those together? So over here, I'm going to multiply A and C. So I'll have 1 times -5 gives you -5. Now, in this method, you need to now look at the factors of -5. So let's just look at that. -5, you could have 1 times a -5, or you could have a -1 times a +5. Okay, those will be the factors. 1 times -5 or -1 times a 5. And how you have to compare this is you need to think of what adds to the B, the -4 in the middle. Okay, which of these adds to -4? Now, if you take 1 and -5, that adds up to the -4. That does work. What if you take the -1 and the +5? That adds up to a +4. So what you can decide is that will not work, but these factors do work. All right. So because it adds to the -4 and the -4 came from the middle, we will be using this in the AC method. So I'm going to use the 1 and the -5. But how do you use this? what we need to do is rewrite the problem. So I'm going to rewrite the problem right below here. You have an x squared minus 4x minus 5. Now I can rewrite this as x squared, and I'm going to leave a space here and minus 5. Okay. Now what I'm primarily working with is this negative 4x. You see how we added something to give a negative 4, and we decided that these two values work out for us? What you can do is rewrite that middle part as a plus 1x minus a 5x. Okay. Now, add 1x and negative 5x. What do you get? You get negative 4x. So this is an equivalent statement. This is a totally valid way of solving this problem. Now, what you do next is you have 1, 2, 3, 4 terms. You have 4 terms now. What you want to do is look at the first 2 together, and then I will look at the last 2 terms together. And I need to look at what's in common in the first 2. We have an x squared and an x. What's in common is a single x. A single x, that would leave you with an x plus 1 as the remaining factor. The last 2 terms, you have a negative 5 and a negative 5. What's in common with negative 5x and a negative 5? A negative 5 is definitely in common. Pull out or factor out the negative 5 from the x, just an x remains, and the negative 5 factored out would leave you with a positive 1. Because if you distributed that back through, you'd have a negative 5. Yes. And then notice what we have overall. We have one big grouping here and a second big grouping here. What's in common with the first and this last term? Hopefully you can see here you have an x plus 1 overall that's left in common. So I'm going to factor out the x plus 1 here. X plus 1. And then what remains is an x and a negative 5. Does that match our solution from before? X plus 1 times x minus 5. In our guess and check, x plus 1, x minus 5. It did work out for us. So this is a totally valid way. Now what's cool about the AC method is the AC method always works. Always. So that is why I'm showing this to demonstrate. Now, I am going to show an alternate way with this. When we got to this step, we wrote that middle part as an x minus 5x. Now, why couldn't I have done minus 5x plus x? You might have been wondering about that. Those are equivalent, right? It is totally fine to do that. So what we could do, if you noticed this, I rewrote it. What I want to do now is just look at the first 2 terms and then look at the last 2 terms and see what's in common. We can solve it this way. Now x squared and a minus 5x, that just has an x involved. And you'd be left with an x minus 5. Now, looking at this last bit. This last bit is a trickier one. What's in common here? You have an x and a minus 5. Really nothing, right? Nothing is there. Since there's nothing, the only thing I can imagine, see, there's a plus, so I'm going to put a plus 1. If I factor out a 1 from each of these, a 1 times anything doesn't change anything. But the purpose of doing this is now when you look at the whole thing as holistically all together, notice you have a parentheses x minus 5 and a parentheses x minus 5. That leaves you with x minus 5 in common, and then what remains Look at that, x plus 1. Are these two things the same answer? Yes, they are, because with multiplication, order doesn't matter. You can imagine 2 times 3 is the same as 3 times 2, right? Or 1 times 2 is the same as 2 times 1. Order doesn't matter with multiplication. So we have our solution. Thank you for watching my video.